because like there's a turning point there.
And so why can't you? What's wrong with there
So
being a turning point?
when you differentiate, you would just have zero, so you can't use that.
Yep.
So would you just do 2 minus, wait, what's the first into differentiate it?
So yeah, differentiate it.
So it would just be 2 minus um 8. So for the first one I got 28 over 15. I don't know if that's right though.
Okay.
But it says you have to do it again, so we'd use 28 over 15.
Mm-hmm.
I got 1.856 as the answer.
This. I'm getting 1.854. My first one was 11 over 6. We shall investigate.
Wrong.
I'll see you in a sec. Part C.
Oh, so you have to do. So since it was 28 point. Wait, what was it now? Wait, not 28. 1.856, I think. So you have to do like 1.855 and then 1.857.
Yeah. Actually, I see where I went wrong. And so, what would you do with those two?
What's that?
What would you do with those two?
Oh, you put it in to the Newton-Raphson formula.
I don't believe so. Yeah, I'm getting 28 over 15.
Oh wait, do you not put it in the Newton-Raphson formula? Put it into FX.
Your answer for part B. I believe you put it into FX. Yeah.
Yeah, into FX. And then you'd have like a sign change.
Yes.
Yeah.
Let me see. What would you put into?
Like 1.855 and 1.857.
To show it to 3 decimal places, you have
Oh,
what you.
okay. So 1.8 1.555
Yeah.
and then 1.8565.
Yes. And you would say the sign changes. What else?
Huh? The sign changes. Oh, the function is continuous.
Mm-hmm.
So there's a root.
Yes. Well done. Yes. And that's how you do that. Grand. Any questions about any part of that?
No.
Okay. And so you differentiated it. So I just used the derivative thing in my calculator. Answer minus, so on the top.
It was really long.
Yeah. Your way is probably better. Derivative on the bottom with just x's. Okay. And that's Newton-Raphson. Let us take a look. Exam question. Is this worth doing?
So when I differentiated, I got 2x plus 4x to the minus 2 plus 6.
Okay.
I don't really get like the second part. Like, what does it want you to do? Does it just want you to put in minus 0.4 into the Newton-Raphson formula?
Yeah.
Oh, okay. It's just like the wording is really confusing.
Life is confusing.
Got minus 0.326.
6 minus 0.326. Great. Any questions there?
It's not actually that hard.
I agree. However, that's kind of the simplest possible thing.
Like this. Yeah.
No, this is fine. It's just the.
It's just doing carefully.
How would you do? What is question A? One marker.
So it's because it's a turning point, so you would just have like 0 as the denominator.
Yes.
You can't do it. But it doesn't tell. Oh yeah, it does. Okay.
And other than that, it's fine. It's just.
Yeah.
And if you're not sure how to differentiate it, calculate it.
Yeah.
And maybe. So on my one, I'd x is on the bottom, but the x that you sub in is answer. And so it's just you're subbing answer into the derivative. I think this is very similar. Am I right?
Yeah. This one.
Similar. Very similar. Very similar. How would you differentiate this bit? X grid settings? Yep.
Wait, no, product rule.
I would just use calculator again, but anyway. Explain why x is not suitable. X0 is equal to A. Where is A?
No, I think
stationary points. Yeah.
Yeah.
Very similar. Hang on. That's question 6. Ln. What would be the derivative of ln?
1 over 3x minus 4.
Almost.
Mm.
1 over 3x minus 4. What's the derivative of 3x minus 4?
Oh, times 3. So 3 over 3x minus 4.
Yeah.
Minus 2x.
And the rest of it is fine. It's all, that's just differentiation, really.
Yeah, I like this topic. Once you learn it, it's
Yeah.
I like this part of it. I don't like the stuff we did last week.
Yeah. Okay, Newton-Raphson, what do you give yourself?
That's pretty easy. Okay. Do you get the formula or do you have to learn it?
You and your questions. I don't know. It seems like you'd have to learn it. It seems like
it's not that hard even if you do. So
yeah, xn minus function over derivative of function of xn. Okay, let's try this one.
It's like logs or something.
This is applying Newton-Raphson to the real world. My least favorite of all worlds.
Doesn't matter whether you're in degrees or radians because it doesn't say.
Oh, because it's sine x?
Yeah.
Try degrees. My guess is it's
2,779.5. That looks right.
Did you do the f of 10?
Yeah, I did. I did x is 10.
Change to
radians.
Yeah, try radians.
$3,497.
There you go. That's what they wanted. Radians it is.
It's in radians. That's really weird. So in the exam you do radians, or would they tell you?
I think for year 2, it's radians unless they say degrees.
Okay, so it's just radians then.
I think so.
Show that hex has a root. Okay, so you just have to put 19 and 20. Bad. So for f of 19, it's 534.1.
Okay.
And 20 should be negative. $20 is minus 331.55. So there's a sign change and the function is continuous. Would you have to check that the function is continuous?
Is there a fraction with x on the bottom?
No, so it's okay.
And it's continuous.
So there's a root between 19 and 20.
That's it.
Find f dash x. Oh my god. How do you... How do you differentiate like 0.85 to the power of x?
I think it's...
I swear there's like a formula, but I don't actually. It's like a to the x ln a or something.
I think that's it.
So I got 0.85 to the power of x times ln 0.85 plus cos x.
0.85 to the x.
Ln 0.85. I didn't like work it out. I don't know if you meant to.
Okay, no, that's fine. What else?
Plus cos x.
Is that it?
Yeah, there's only two terms.
What happened to the 15,000? What happened to the 1,000?
I don't know. Yeah, it's only 15,000 and 1,000. I don't know why they just disappeared.
And that would be 1,000. Let me check. Ln.
I think it's before that. It's pot C. Yeah, it's right.
Ln that. Yeah. Wait. Minus 1,000.
Why? Why is it? Doesn't it differentiate to minus cos x?
Negative sign. No. Wait. Yeah, that would differentiate to be negative cos x. You said plus, didn't you? Yeah, that should be negative.
Why?
The integral of negative sine x is positive cos x.
Oh, okay.
The derivative is negative. Yeah, it goes plus, plus, minus, minus. And next one.
I'm 19.486.
19.486.
Yeah.
Well, maybe you're right. Maybe I'm wrong. 19.486.
This model.
Method 1, subtain second approximation.
Oh.
19.528. Did you just put something in wrong somewhere?
Maybe.
So 15,000 times 0.8 to the power of, and was your first approximation like 19.5? Is that what you're subbing in?
Oh, I put 19. Maybe that's why.
I think you've got the idea.
Yeah.
Part A.
Um, the value of the car is going to decrease as it gets older. I don't know why that's a criticism of the model,
So,
but it's not going to be negative.
so let me go back to my calculator. I'm just going to keep pressing equal, see what happens here. Ooh, time out.
Why would the value be negative? How would it be
I don't think it would
negative?
be.
Exactly, but f of 20 is negative, so that's the criticism. The value.
The f of 20 is negative. Yeah, so that's it. The car won't have negative value. Maybe.
Exactly.
Yeah. In reality, the car can never have a negative value. This model is not reasonable. Yeah, there we go. Any questions there?
No.
Okay. Let's see, this one. Is this worth doing, or it's very similar?
It's basically the same question.
Yep. How about this one?
So these are basically just differentiate, like as long as you differentiate it correctly.
True, if they ask you to differentiate it, which they tend to, but I didn't differentiate it. I just did d by dx and just let the calculator.
But they probably would like make you do it.
It looks like that's what they're doing. They're making it, every question.
Yeah, because they know you can use the calculator.
Yep, same thing. Oh, what is question E for this one? Can we do it without doing everything else?
I don't even understand what that means. Oh, like when is it valid? I think.
So suggest an improvement. So he throws a ball
It's
for
only
his.
valid till the time reaches A. It's not valid after that, I guess.
Hence suggest an improvement.
Oh, increase the range of validity of the model.
I don't know. So he throws a ball for his dog. The vertical height of the ball is modeled by this function. So that's time, that's height. The t coordinate of A is this. Yep. Find that. Take 8 second approximation. For when the height of the ball is 0. Okay, hence suggests an improvement. Let's see. Restricts the range of validity to between 0 and A.
Or restrict it to 0 and A.
Yeah, there you go.
How is that an improvement if it's already like?
I think it's because if you subbed in like A plus 1, you'd get a negative value.
Okay.
I think that's what it's about. Yeah, I think it's going to be like a sine wave type of thing, and it's going to go underneath.
But it's a ball. How can it have a negative height?
So that's why they're saying you should restrict the.
Oh, okay.
The range. Try to make it.
Got it.
More like a function.
The phone is not going to have a negative value.
Sorry?
Part D. Let's criticize this model with respect to the value of the phone as it gets older. It's not going to have negative value.
So we're assuming that this is going to create a negative value. Yes, create a negative value. We're right.
So literally for any of these questions, it's just like it can't have negative.
Looks like it. So, well, what we're doing is section 4, which is modeling. So this is applying it to the real world. And so it looks like lots of real world applications can't be negative. So like you can't have a negative number of crimes. Okay, how about question E, last one. So this starts from the year 2000.
How are you meant to like find October 2000 on the graph?
October 2000. So there's one. And so it'll be a little bit before that. So I assume that they're referring to that dip.
I'm guessing maybe was increasing.
And June 2003. So
Yeah, that's
3 is there. So it's probably.
yeah. The model supports this claim because the curve has a positive gradient
See?
between these
Who
times.
knows? The model does support the assumption that the crime rate was increasing. The model shows that there is a minimum point 3/4 of the way through 2000 and a maximum point midway through 2003. So the crime rate is increasing in the interval. Yeah, there you go. So you'd have to just write that whole thing. All right. Great. This one, bungee jumper, looks very similar. Show that sometime between 2 and 3 seconds. Okay, what about question B?
The jump is not safe because, like, right after 3 seconds, there's a minimum point, so the jump is touching the ground.
It's slightly above that.
Okay, but they're like really close to just touching the ground. Definitely less than 10 meters.
I don't believe you can do that by inspection. This might just be a sketch. So
Okay.
how could you verify it?
Find where the root is.
And how would you go with that?
Sign change.
There is no root.
I don't know. Newton-Raphson formula.
There is no root.
I don't know how to do
it. What do you know about this here?
It's a parabola.
This bit down there.
It's a minimum point. I don't know.
Yeah. What do you know about minimum?
Oh, dy by dx is equal to 0.
Yes. So what you were saying with the root is that, in this case, h.
But that would just give you the x coordinate, though. Okay, but then you can get the h. No point.
Yeah.
Okay, but I'm still going unsafe.
Prove it.
Because you know the first bit, it says between 2 and 3 seconds, the bungee jump is exactly 10 meters. So like here, you can't see it, but like between 2 and 3 seconds, if that's exactly 10 meters, then like the bit after 3 is like literally like near the ground.
Show that sometime between 2 and 3 seconds after the person jumps, the bungee jump exactly 10 from the ground. Yeah, I like your reasoning actually. Part B is a 1 marker, and so I think you could probably just get away with saying it. Show the equation can be written as that, and then using that, yeah. So if you had to find that, you could do dt by dh, make it equal to 0.
Okay.
At t equals 3, person is approximately
Okay,
2.1 from ground, jump is not safe. Oh, they went even simpler. They just subbed in 3.
Oh, okay.
And it was less than it. Well, that's quite lucky on their part. Okay, applications to modeling.
Yeah, it's okay. It's pretty easy.
Done. So
is that this whole chapter? Like that's all there is?
Yeah. So after that's mixed,
okay.
Function continuous. Yeah.
I have like 30 pages of notes on this for no reason.
Yeah, it's numerical maths is very easy. I like it, to be honest. Like
yeah, it's not hard.
It's just for approximating stuff, so it helps to get an exact number, like, you know, if it's e or something, or ln 3, but Oh, what is this? Google always does this. Like, oh, it starts showing me all these celebrities who are also have the same name.
Celebrities with the same name.
It always does that. Okay. What are we doing next?
Differential equations. I understand nothing.
You and your differential equations.
I've never done it before.
They're very, very difficult. Let me just see.
I know. Our teacher set us this. She spent like 10 minutes in a lesson teaching it to us, like not even joking, 10 minutes. And then she set us this really hard thing last week and no one knew how to do it.
Find.
And then this guy complained and she ignored him.
Okay. Solving differential equations. Sure. This is chapter 11. Let me just check. In mine it's chapter 11. Is this... I might just have this already. Yep. We got lucky.
Integration.
I have my old notes on these. We'll use this, see how it goes. Come on, downloady.
Oh, also, apparently there's like a bit of proof that we're meant to do in year 13.
There's lots of proof that you need to do in year 13.
Is there a lot? Apparently there's like one other method.
Well.
Something called proof by contradiction, I think.
Yeah, that's, you assume the opposite is true. You try to prove the opposite.
Yeah, that one. I don't know that, so I need to know that.
Why don't you ever ask me for something easy? Actually, numerical methods was easy.
Because they left all the hard stuff till the end of the year, and then those. So
your teacher started the coronavirus just to get out of it.
Probably did.
Okay, this one.
And one of our maths teachers abandoned our class, so we have one teacher now.
Why? How did they abandon your class?
Basically, the really bad like maths teacher that we had, she left like 1 month ago. So we got a new teacher for like 1 month left school, but he's really old, and I don't think he can do technology, so he's abandoned our class now.
Wow. Okay. Separating the variables. Sure.
I don't know how to do that. I don't even know what that means.
Yeah, we don't need to worry about that stuff. Okay. Any idea how you do this thing?
No idea.
Let me guess. Here's my guess. My guess is you do dy by dx by dividing both sides. No, maybe you don't do that.
What does it mean by find a general solution?
Ah, I remember these things now. A general solution means it's plus c.
Aren't they always plus c?
A specific solution would be if they gave you a point on the graph, something like that.
Okay. So you don't need to find what c is, basically.
Yeah.
Okay.
Yes, I remember these. So this is gonna look magical, and it kind of is. I multiply both sides by tan y.
Okay.
And I divide.
Then wouldn't you have to divide y on one side?
And I divide both sides by 1 plus x
What?
squared.
Okay.
So I am left with 1 over tan y dy by dx equals x over 1 plus x squared. And then the next piece of magic is you can think of it as multiplying both sides by dx. Actually, what is 1 over tan y the same as?
Sec. Nope, not sec. There's another one. What's it called?
Its third letter should be a T.
Cot. There we go. I once said I think I once said that 1 over tan was cosec in front of all my friends who do double maths. It's not a good time.
What did I just do there?
I don't know.
So we had
You divided by dx or something. No, you multiplied by dx.
Sure. And I now have cot y dy.
Do that?
You can
But
now.
You multiplied, yeah, okay. You did multiply by dx.
And next, you integrate both sides. And so it is the integral of cot y with respect to y and the integral of the x's with respect to x.
I don't know what cot y is.
Are you going to make me look it up?
I could look it up, but...
You look it up, yay. Is it something to do with sec x or something?
I'm looking. Keep getting videos. I don't want video.
You cheeky this man.
Ln sin x.
Whoa, what is it?
Ln sin x. I'm not sure if that's right, but...
Ln sin x. Alright. Wait, so in this case it'd be ln sin y. Equals...
equals x over 1 plus x squared.
Integrate it with respect to x.
Oh, x squared over 2 and then
how did you get x squared over 2?
Wait. I just did x multiplied by 1 over 1 plus x squared. So then when you integrate the x, you get x squared over 2. But I don't have to integrate x squared plus 1.
You told me some trick.
Oh,
the
you can
derivative,
do
is it?
2. You have to multiply by 2.
Yeah.
And then add half. Oh wait, no, you have to multiply by half and then add 2 there. And then you can just do ln of 1 plus x squared. Yeah, that makes sense because then they're both ln. So then you can just raise the whole thing to the power of e.
You could. No one asked you to do that though. Don't forget your plus c.
Yeah. Okay. I still don't get these. But
let's just check. Ln sin
wait,
y.
half.
Yeah, we forgot our half. Half. Or. Yeah, so just lots of different ways.
It says remove the ln.
Sorry?
It says remove the ln at the end.
So you do remove the ln. Okay.
I mean, they're both ln, so it's not that hard.
So, well, that one's going to be sin y.
I thought it was just ln.
Sorry?
Wait, how do you say it? I thought it was just ln.
Ln? Yep. Sorry, I thought you were referring to mathematically.
No, just how do you say? Okay, sin y equals half 1 plus x squared. No, that's not right. E to the half. 1
No,
plus x.
no. Before you do that, you have to make it a ln as at the front. You can't have a half at the front.
Oh, how do you do that?
Log rules.
Oh, ln 1 plus x squared to the power of a half.
Yeah.
So then you have sine y is equal to 1 plus x squared to the power of a half plus c.
The power of a half. It's actually plus e to the c, isn't it?
No, because you could just add the constant at the end.
So in that case, I would probably just refer to the constant as a.
Why?
Because it's not the same as this one.
Oh.
But we can't possibly know what this one was, and so it's kind of meaningless to say like e to the c or something. 1 plus...
Why can't you just write plus c at the end? Like if you didn't write it before.
It's because it kind of implies that it was this... that these
Wouldn't
two numbers are the same.
Wouldn't it be the same? Because you integrated it, so wouldn't...
It would be like e to that power.
Oh, it would be e to that. Okay, that makes sense.
Yeah. And they did it by sine y is equal to k 1 plus x. Finally move the line. Sometimes you might be...
Why did they do k? Is k the constant? Why did they do multiplied by?
So ln sine y equals a half ln plus ln of k.
Why? Where'd you get ln k from?
Don't forget the plus c, which can be written as ln k. So they wrote plus c as ln k so that they could incorporate it here as a coefficient.
Yeah, that makes sense.
Oh, that makes sense to
You
you?
have to do that.
Sorry?
You have to do that though.
I think it will make it easier to solve for an exact solution later on. Let's see. Oh, hang on. So before we go past it. So this was the question. The trick is get all the y's on one side, get all the x's on the other side. Dy on one side, on the y side, dx on the x side, and then integrate both sides. And that way you're integrating with respect to y on one and integrating with respect to x on the other. And that's why it wasn't implicit differentiation. Okay, how about this?
So you just have to multiply both sides by dx, so then you have... Oh wait, no. You have to rearrange as well. So you could bring up the, like, take the 2x plus 1 and x plus 2 to the other side. So, like, multiply by them, basically. And then dy over dx is equal to minus 3y minus 2. And then you could multiply both sides by 1 over dy. So then you would have 2x plus 1, x plus 2 dx is equal to minus 3y minus 2, 1 over dy.
Yes, on the right side. This one wouldn't be dx, it would be 1 over dx.
Really? Oh, yeah. Okay.
And how would you bring the dy to the other side?
1 over dy.
So that would be 1 over dy. And so I would flip
them.
Sorry?
You'd have to do 1 over 2x plus 1x plus 2 dx or something.
Yeah.
Would you have to expand the brackets? Because you wouldn't... How would you... I mean, you could integrate them, but...
I think it would help to expand.
Yeah, that's what I think as well. 6. Well, on the right side, you would have 1 over minus 3y plus 6. Differentiate that, you just get minus 3. So you can just put minus 3 into the numerator and put minus 1/3 outside of the integral sign.
Okay.
Yeah, then you could just do ln. Then you just have ln minus 1/3 ln minus 3y plus 6. Plus k.
Let's say plus ln k.
Yeah. And then 2x plus 1, x plus 2. I think it would be the same method, like you have to put the derivative on top. But I feel like that would be hard. So when you expand it, you get 2x squared plus 5x plus 2.
Mm-hmm.
So on the top, you would need 4x plus 5. So if you do 1 over 4x plus 5 on the outside, I don't know if you can do that.
You can't have an x on the outside.
Okay, then I don't know how to do this one. Wait, no, I don't know how to do it.
I think you could write it as a
you
half
can-
x to the minus 2. Can you do that?
Yes, I think.
So 1/5 x to the minus 1. That's the same as 1 over 5x. I'll leave it as 1 over 5x. No, I'll leave it as 1. Yeah, 1 over 5x.
I mean, you could do 1 over 5x to the minus 1. It wouldn't be wrong. It's probably just easier to integrate.
Okay.
Oh, you need to put an integrate sign there, yeah. Because that side's already integrated. But we didn't integrate the left.
Mm-hmm.
Yeah, then we have to integrate that.
Mm-hmm.
So x to the minus 1 divided by minus 1.
Yep. So minus half x to the minus 1.
Yes.
Okay.
It's 0.5 divided by. Yeah. And then that would just be 1/5 ln 5x.
1/5.
I'm confused. On my sheet, it says for 1 over ax, when you integrate it, you can have 1 over a ln ax or 1 over a ln x. How are those two the same thing?
Say it again, sorry. 1 over.
You could have, when you integrate 1 over ax, you could have 1 over a ln ax plus c or 1 over a ln x plus c. I don't understand that. How could you have both?
Yeah, that doesn't seem right.
Yeah, I think that's wrong. I'm crossing it out. I did not see that before, but okay, and then half would just be x over 2. Half x.
Plus a half x.
Wait, no, it would be 2x.
Nope. Half x.
Nope, it would be half. Yeah, it's
Okay.
confused.
And that's equal to the other side. And then
These are so confusing.
then how do we do this?
Oh, and then you have to substitute and then find what the constant is.
Yes. So you sub 1 for x, 4 for y.
You want y equals f of x, so you should just substitute x. X is 1 as well. That's way easier.
Yeah. So x is 1, y is 4, and what are you trying to solve for?
Ln k.
Uh-huh.
Yeah.
And
Am I doing it? Okay.
let me just check that we've actually done this bit properly.
It's so hard. I'm never going to get this.
Let me check.
I think we did something wrong.
We did it by partial fractions. That will make things easier.
I did not even learn how to integrate partial fractions.
It's just like the ln stuff.
Skip. Yeah, it's just ln. But
ln x plus 2 minus ln 2x
Wait,
plus...
you know how their partial fraction had like 2 over 2x plus 1? But when they integrated it, they just ignored the 2 on the top.
They rearranged it to make that happen, I believe.
Ah, okay. Really?
Because 2 is the derivative of the denominator.
Okay.
So they used partial fractions. Yeah. Did you do partial fractions?
I didn't do it for this question. I know how to do it.
Okay. So they did partial fractions. All right, that would have been much easier actually. Partial fractions.
Yeah.
I think this is wrong.
Yeah, I think it's wrong too.
Yeah. This is because we can't split them up like that, I don't think.
Way too complicated for A level.
Okay. But the method is right. Sub in 1, sub in 4, and then solve for ln k.
Okay. Still get these, but
They solved ln k. They got k is 2, and then it's just y equals... and then you have to make y the subject.
yeah, it says y equals f of x.
Yeah. Okay, any questions there?
No.
Okay, let's see. Exam question time.
That was an exam question.
Nope.
Oh no.
This is a
Ooh, x equals 0 and y equals 0. That means the constant has to be 0 as well.
Nope.
That doesn't mean the constant has to be 0.
Well, here's a 1. So, not necessarily.
Oh, not necessarily. I haven't known how to solve this though.
All the y's on one side, all the x's on the other.
But there's one with both.
I have an idea.
Oh, you can factorize that so you get 2y1 plus x. And then you could divide by 1 plus x. And multiply by 1 minus y squared.
What would you get?
2y, 1 minus y squared is equal to 1 plus x. I think. And then dy on that side and dx on the x side.
This side wouldn't be 1 plus x.
No.
This is times 1 plus x over here.
Oh, 1 over 1 plus x. And then dy on the... and dx on the right, yeah.
That's it.
Is that right?
Mm-hmm.
That's right, okay.
And then, oh, no, something's not right.
Yeah.
Well, this was 1 minus y squared over here. Over here it's going to be...
1 over 1 minus y squared.
Yeah.
I have to do it like one step at a time, otherwise I'm going to get it wrong.
I agree. 1 over squared. Okay, what is next?
On the left side, it's the derivative. 2y is the derivative of 1 minus y squared. Is it? No, minus 2y is.
Mm-hmm.
So you can just put in a minus and then put a minus outside the integral.
So 2y over 1 minus...
No, minus 2y.
So we integrate both sides, and this one we put, let's say, minus 1 on the outside.
Yeah, or just the minus, but yeah.
Okay.
And then, 1 is also the derivative of 1 plus x.
Okay.
So you would just have ln 1 plus x and ln 1 minus ln 1 minus y squared. Plus ln k.
Okay.
So then when you put everything to the power of e, you just have minus 1 plus y squared. And then 1 plus x plus k.
Let me think about this. Minus 1 minus y squared, is it?
No, you wouldn't have plus k. You would have k multiplied by 1 plus x on the right.
And so this one can be written as
K 1 plus x.
ln k1 plus x. This over here.
Yeah.
Remember, we have to have
1 minus y squared to the power of minus 1.
Yes.
Log rule.
Because we have to have just ln at the front.
Yeah.
Can't have anything else. Okay.
But even if you had the minus, okay, you'd get the wrong answer. Never mind.
And so you raise both to the power of e. And what is after that?
You have to solve for ln k. Oh, just k, not ln k, just k.
Mm-hmm.
So 1 minus 0, so 1 to the power of minus 1. 1. So you would have 1 on the right, no, on the left, yeah. And then you'd have k on the right. So k is equal to 1.
K is equal to 1.
And then you have to make y the subject.
Yeah.
First you'd have to take away 1 from both sides.
Why is that?
Oh wait, you can't do that. Never mind. Oh, you'd have to like multiply 1 minus y squared like to the other side and then divide by 1 plus x. I want to make y the subject because it's to the power of minus 1.
Kind of. I'd sub that in now that you have it. So that's just times by 1. Okay, so you times both sides by...
So you have 1 over 1 plus x. No, you shouldn't have 1 over 1 minus y squared. Oh, you're just writing it out. Okay.
I'm just writing it a different way.
Yeah.
Okay.
So you like swap 1 plus x and 1 minus y squared, basically.
So 1 over 1 plus x equals 1 minus y squared.
And then you have to take... You can just do y squared is equal to 1 minus 1 over 1 plus x. And then just square root the whole thing.
Okay.
Or you can just do that in that step, yeah.
Minus over 1 plus x. And then square root the whole thing. And there's a few different ways to write that. I'm just curious as to... oh, yeah. So y equals... So they actually added those two together. I was just wondering if they would do that, but you don't quite need to do that. Like this is the same as...
It's the same.
1 is the same as 1 plus x over 1 plus x.
Yeah.
Yeah, so x over 1 plus x. Yeah, same thing. Great. Any questions there?
No, but these are still hard.
Yeah, told you there were, and there's lots more particular solution. But the big idea is get all the y's on one side, get all the x's on the other side, dy, dx, integrate both sides, solve for k by subbing in the x and y, and then make y the subject. Yes, and so that way it's basically integration, and they give you a point, and you use that to find the plus c. What do you give yourself for partial fractions?
Partial fractions? Oh, differential.
Differential equation, sorry.
Like, I don't know. I won't do like more on them because I don't really understand them properly. Maybe like in between the half and the tick, but like more towards the half. Yeah.
We can do more of those next time, and then modeling with differential equations.
Okay. Fun.
Yeah. How was that for you, Amogha?
The numerical methods is fine, but the differential equations was like a bit hard.
Yep, sure is. Told you.
I will back next week.
Sorry?
I want to do differential equations again next week.
Okay. Any questions for me in general?
No.
All right, well done, Amogha. You did great.
Thank you.
I look forward to chatting again next week.
Bye.
Have a good week. Goodbye.